Now see a Gauss's law, or that is called Gauss theorem. See here, this by using the Gauss's law or Gauss theorem, we can calculate electric field due to the different types of the body having the charges, and this is the simplest method to calculate electric field. Now see here, suppose there is a charge q and it is enclosed by any type of the surface. We do not go for the what is the shape of this surface, shape and side does not matter. So actually, if this charge is enclosed by this surface, then the total flux through this surface, total electric flux through this closed surface is given by here vector E dot vector ds is equal to q by epsilon naught. So according to Gauss theorem, the surface integral of electric field over any closed surface is equal to 1 upon epsilon naught times the net charge enclosed by the surface in vacuum. This is known as Gauss theorem. So the total flux or electric flux through this closed surface is equal to q by epsilon naught. This flux is independent of the shape and size of the surface here. So now we can explain this Gauss theorem here, or we can take its illustration. Suppose you have got any charge q here, there is a charge q, and now this charge q is here enclosed by a surface of this radius r. So I have taken here symmetrical sphere. So this charge is enclosed by here this sphere. So let us take here any small area over here, whose area vector is to this side and electric field is to this side also, radially outward, because it is here the positive charge. So now we can write vector E dot vector ds is equal to E ds cos theta, theta is equal to 0. So we can write here E ds, E at this distance r is q upon 4 pi epsilon naught r square into, here we can take integration of this closed surface, that is ds. So we can write here q upon 4 pi epsilon naught r square into, when you integrate this ds over this surface, you will be getting 4 pi r square, this and this will get cancelled. So you will be getting q by epsilon naught. So the total flux due to this charge through this spherical surface is equal to q upon epsilon naught. And this sphere, when it is drawn here, you know, and this for the calculation of the electric flux or the electric field. So this surface is known as a Gaussian surface, and Gaussian surface is drawn in such a way that at the every point electric field remains same here.